Hi, our project is the AI-driven smart traffic management. And so, for introduction, what is the problem we face? First is because of a traditional traffic system rely on the static timers that fails to adapt to unpredictable traffic waves. The road situation will not affect the light time of the green light and the red light. So maybe when sometimes it is a green light but there is no car, or when the red light but there is a lot of car. So the solution that we propose is using an AI-driven system that use a custom physics engine to simulate vehicle behavior and Google Gemini 2.5 Flash as an AI analyst. Whilst our objective is to evaluate real-time telemetry throughput, demand, and backlog to dynamically justify phase timings and prevent city traffic jam. So we hope that we can using the AI to analyze the road situation and then reflect to the light time of the green light and of the traffic light. So when maybe there is a big jam, the green light will have a longer time. Next is a case study. So after we have doing some research, there is 3 projects that we can use as a reference. First is assess called Smart Traffic System in Malaysia. It uses the camera inputs to detect traffic volume and reduce waiting times up to 40% during peak hour. Next is in Indonesia, the Jakarta Intelligence Traffic Control System. It is a collaboration with the Google to analyze the vehicle density at special intervals. So since we can analyze the vehicle density, then we can analyze when is a peak time, where is the most vehicle. And the third one is the Alibaba City Brain at Hangzhou, China. It uses snapshots instead of the continuous video to save the bandwidth, as a video is much more larger in file size, while although using a snapshot, it is still accurately identifying the congestion patterns. And third is a software use. We have used 4 softwares in our project. First is a Microsoft project. It is used in our documentation, such as used to create a Gantt chart, assigning resource to tasks, tracking the critical path, and managing the project timeline. Second is a GitHub. It is used to facilitate the group collaboration where team members could push code updates, track issues, and discuss coding logic. We can also find the latest version of the code in the GitHub without keep on asking, and it will maybe due to the communication. Third is the Python, which is the core programming language used to script the snapshot analysis logic. And the fourth is the Google Gemini 2.5 Flash. It serves as the AI as a cognitive layer by transforming the raw telemetry JSON data into professional, actionable strategy reports.
I am Wong San Le. I will talk about the AI project management, and we have 5 steps. The first step is initiating, define project sector and validate the AI solution as more cost effective than infrastructure as mentioned. The next step is planning, develop a work breakdown structure WBS, covering simulation, logic, UI, testing, and documentation. Then the executing, build the feature engine and integrated the Gemini API for manual reviews. And that's the monitoring and controlling part. We use GitHub issue to resolve algorithm instability and UI race condition. The last step is closing, successful prototype demonstration, final code base committed to GitHub and lessons learned documented. Now is the system flow part. Let's see the stochastic input. It usually like a pattern generator that spawns vehicle 2 until 8 units with unique IDs and specific direction. The physical processing, the engine run at 20 Hz, calculating acceleration with 0.15, deceleration with 0.3, and safety buffer. The telemetry analysis and intervention aggregate data on phase throughput and waiting load data. When the timer reaches 0, the system DB and AI interventions that poke in the physics engine. The last one is AI justification and translation. We use the Gemini 2.5 Flash AI analysis, review the JSON, telemetry, and calculate the optimal duration for the next pass. The brain of this system is our demand-weighted fairness algorithm, which balances efficiency with clarification through two main components. The one of component is timer calculation logic. We calculate the green light duration using a specific formula. Baseline equal active car multiple 30. This plus 100 tricks. The fairness product is a value exceed 15 cars. A product is applied to prioritize that length. The final equation is new time equal base time multiple 0.4 plus standard ratio multiple 0.6. The sampling to prevent extreme result are claimed between a minimum of 5 seconds and a maximum of 16 seconds. This is the six-phase rotation cycle. To handle complex four-way intersection, the algorithm cycle through a specific sequence. Phase 1 until phase 2 focus on vertical movement. This is straight or left, followed by dedicated right turn for lanes 1 and 2. The phase 4 until phase 6 focus on horizontal movement. This is straight and left, followed by dedicated right turn for lane 3 and 4. Thank you.
Moving on to the problem-solving section. The first is the starvation problem, which is a common issue in traffic logic where busy roads hold the green light indefinitely, preventing side roads from ever moving. The solution is we implemented a fairness throttle to force phase changes to ensure network equilibrium. Second is the yellow light ball logic. Initially, our simulation caused vehicles to make abrupt stops or run red lights because they couldn't decide what to do during a yellow signal. The solution is we program a 20-unit threshold for commit or break decisions. The third problem we face is AI latency and desynchronization. Because the simulation runs in real time, the state of traffic will change before the AI finish process its decision. The solution is we created an AI intervention free state to sync logic with the analyst. Now let's look at the problem implementation. We adopted a real-time telemetry and agent simulation methodology. Unlike the traditional system that rely on bandwidth-heavy video processing, our system process raw JSON telemetry data. This mimics a modern V2X vehicle-to-everything IoT environment, where smart cars transmit their position, speed, and turn intentions directly to a centralized edge computing node. The system was stress-tested using virtual platoons that randomly generating waves of traffic to ensure the AI analyst could handle sudden surges in demand while maintaining city-wide fairness. For project output, the top right is the visual countdown for the 6 distinct rotation cycles. The left bottom is the high fidelity visualizer tracking real-time vehicle counts and cumulative throughput. And the right bottom is the AI analyst, which is powered by Gemini 2.5 Flash, providing performance, strategy, and impact reports.
Okay, hi, my name is Liu Kaiwen, and now I'm going to present the Gantt chart using Microsoft Project. Okay, so this is our Gantt chart that we built using the Microsoft Project, and this is the work breakdown structure. And next, we are also using GitHub for the communication purpose that all of members will push their code by part to the GitHub, and also we have also communication between team members using the issue in the GitHub part that maybe we have some bug or performance need to redo or need to enhance it. Okay, so the last one is the conclusion. The AI-driven smart traffic system successful demonstrate that artificial intelligence could move beyond static timers to create a dynamic, fair, and efficient traffic management. By integrating Microsoft Project for lifecycle management and GitHub for technical collaboration, our team delivered a functional React-based prototype that used a custom physics engine and Gemini 2.5 Flash for the cognitive analysis, and the system successfully identified vehicle density, then applied a fairness throttle to prevent the gridlock and adjusted signal timers to optimize the throughput. So our future improvement could include also the emergency vehicle detection, which is the ambulance, to automatically trigger phase overrides, granting them an immediate green light path. Okay, thank you. Okay, so hi, this is our demo part now. So this for our AI smart traffic management system. So this is the overview of our system. So we have phase 1 to phase 6, then it will look back to phase 1. So this is our live traffic density. Our live traffic density have the dynamic timing. Instead of just the fixed timer, the system calculate green light duration based on the number of active lane vs the waiting lane. Then we also have the fairness logic, which it prevents the starvation by shortening the green light if opposing lane are heavily congested or there are no cars inside the lane when it is active. Then we also have the AI analysis, which act as the agentic AI part for it to have the performance strategy and impact. Like as you can see, we have 24 vehicle demonstrating reasonable throughput because 5 plus 6 plus 6 plus 7 car move through this phase. Then the next phase is going to be 9.4 second duration. Okay, now let me try to press this. Okay, so as you can see, this 9.4 second for next phase to move. Then it will also again to generate the AI analysis part. Then after the AI analysis, we will loop until the end. Okay, thank you.